Hello everyone. In this video, we are going to learn about the knowledge representation using semantic nets. Concept of semantic networks. Knowledge is represented as a network of related concepts. The nodes are representing the objects or concepts, and the arcs between the nodes will represent the relationships. Variants include hierarchical and associative networks. What are the common semantic relations? They are instance, is a, has part relation. When I say instance, it's a specific example of a general concept. Is a relation, it says a subset of a more general concept. Has part, it's a component of a larger concept. Used to model hierarchical and associative relationships. Let us take the cricket domain semantic network as example. Here, we are going to map the cricket knowledge into a semantic network. Team and runs are the values of attributes. The arrows indicate relationships between objects and values. For example, is a relation batsman, cricketer. Instance, Tendulkar is a cricketer. Team, Tendulkar, India, belongs to the team India. This is a sample semantic network, so which explains the various relations, is a instance and has part of relation. As we could see, bowler, batsman is a relation with the cricketer, and Tendulkar is a batsman. So we represent instance, and Tendulkar belongs to the team India. He has runs, say this much of runs. Inference in semantic networks, there are two main mechanisms, intersection search and inheritance. Intersection search finds the common relationships which are existing. Inheritance allows the property sharing through is a relation and instance relationships. They help in automated reasoning and decision making. For example, here we could see it talks about two persons, Ram and Shyam, and what the runs they have. Now, this is a network, a semantic network. Here we could see we have added runs 1 and runs 2, which is used to specify the value. What is the score? How much runs Ram has scored and what is the value? This semantic network, the arrow which we have used between runs 1 and runs 2 is the comparison of the runs. So this is the inference in semantic networks. Partition semantic networks. When we talk about the standard semantic networks, there are a lot of problems. It's so vague and it's inefficient in the inference mechanism. Heuristic inadequacy, which leads to weak logical conclusions. That's why we move on to partition semantic networks. Here, the entire network we could divide into logical space. So each space in turn will consist of so many nodes and arcs, and the spaces will be treated as high level nodes. It enables the structured reasoning, and these networks will help us to distinguish between the objects and to control the search space, proving them logically as well as it's heuristically adequate. This is one example for the partition semantic network. You could see the entire semantic network we have divided, and we could see the network is divided into some logical spaces, and each space is going to have so many nodes and arcs. And this helps us in order to, it leads to better logical conclusions, and it is heuristically adequate. That's all with the knowledge representation using semantic networks. Thank you.